distance you have to cover, it's not the most efficient way to do it. So long transit time, high bandwidth, and short frame length would mean something that would send multiple packets would be more efficient in this case. Think of pizza delivery. You have cars, they only have so many delivery, I almost said delivery boys, but just drivers. There's drivers going back and forth between houses. For the sake of argument, let's just say it's all at the same complex and they can only send out one driver at a time. You have, let's say, 26 drivers just going, and they get to the place, deliver their pizza, and come back. And you have a stream just going. And if you have enough drivers and the distance is small enough, you have just a constant flow because the driver arriving back from making a delivery is coming back just as the next sender just went out. So that would be an efficient system. And I would like to discuss for a moment the bandwidth delay product. So you have the bandwidth, you multiply it by the one-way transit time. That gives you P, which is the bandwidth delay. You divide that by the number of bits in a frame, so you get the bandwidth delay product per frame. Multiply it by 2 because it's one way, so it needs to go there and back, and the +1 is for the acknowledgement of the frame. It must receive a complete frame before it can send the acknowledgement back. All right, so let's give an example of this. This is the one from the book. So any of you who read that example have an advantage in this case. The bandwidth is 50 kilobytes per second. The one-way transit time is 250 milliseconds. I'm going to go ahead and start the problem. So you multiply those two, you get 12,500. And then you divide it by the number of bits in the frame, you get 12.5. And that is bits per frame. So can anyone tell me what X will be in this situation? With BD being 12.5.
26.
Yes, I said that. No? Okay. Anyone want a free donut? Donut? Why not? All right, there you go.
So Krispy Kreme.
What this 26 represents is this is like the example with the pizza deliverers. You have them going at a constant rate. So when the last one is sent out, the last driver, the 26th one is sent out, that first driver is just coming back. So at most you have 26, but you could have 25 outstanding frames that are waiting for the acknowledgement to come back. So does that make sense to everyone? Just going constant loop. You will occasionally have one that's fulfilled, so it's 25 sometimes, but it's mostly 26 of the missing one.
I would call that wild traffic.
Think of the 2-lane road, and that's just theirs. All right, so this is pipelining because it's always having the carriers in flight. So that's that motion. And GoBackN is the first method described. It was shown in the video. Here's the problem though with pipelining. There could be one missing. If there's one missing from that train, what happens to everyone else, all those other drivers? Because it has to receive them in sequence. GoBackN just discards all the additional frames, so it doesn't send acknowledgments for any of them. What happens is the timer runs out, as you saw in the video, and that frame on is all resynced. So it just tosses out all the successful ones after that failure. So that's hence the wastebasket just dumping them out. And then you have selective repeat, where only it sends the latest unacknowledged one. It saves all the ones that came in successfully. So if you had a bunch come in, and one, like let's say out of the 26, the second one didn't receive. Instead of throwing out all, 22 others, it saves those and it buffers them. And selective repeat, after the timer runs out, it'll send the latest unacknowledged one, and once that one comes in, it buffers that one, and then it sends them all in that sequence that it originally came in. All right. Oh, okay. So this is cumulative acknowledgement. I don't have the best example for this, but I couldn't really think of anything excellent. Maybe you guys can help me out with it. But acknowledgement for frame n acknowledges all below it, n -1, n -2. It's a fairly simple concept, but I was trying to think of a way to better show it. So I was thinking the 7 dwarfs. If you saw, let's say, Doc in the mine, you just see one of them. You immediately think the other 7 must be there because you think of them as kind of a unity. They're known as the 7 dwarfs. You don't know, you know their names, but they're thought of as a group. So when you see one, you immediately think, oh, all the other ones are in the mine. They don't really split up. So can anyone give an example? You get a donut if you can. But if not, that's okay. You have an example?
Well, you can say that if you get your grades in and you see you got an A, then you know that you didn't get. You know that that's what you got. You know that you didn't get anything worse than that.
True.
Answer two.
You have
Your train example probably works out pretty well as well. Like if you see the caboose, you know that there's cars in the engine. Like I think that's probably
good. Because the caboose is the last car, and immediately you know all the other ones before it made it. That's really good. You can have a donut if you want. Another free donut.
Nodes, you get to the very last one, and obviously, if you get to the last one without hitting a bad point or something, then
Exactly. So, yeah, the main point of the selective repeat is they're accepted out of order, and the problem is the receiver has no way of telling that. They can't. The example in the book was a lightning bolt strikes the computer, destroying all the acknowledgments being sent back. So the sender doesn't think they got through. It'll send the same first 4, let's say, or this example would be the first 6 or 7 rather. In the first one, they'll send the first 7 back again, but they've actually received it already. So the receiver won't know. It will say, oh, I'm trying to receive 7, I got 7, I'm going to put them here, even though that's a duplicate. It just has no way of knowing that. So the way to fix that would be to cut it in half of the maximum amount and send only a portion of it at a time, so that the receiver only has a certain window it's asking for. That way you're sending 2 separate groups, so when the group comes back, the correct window needs to be there. That way it doesn't get duplicates. Not sure if I explained that well enough.